Here we go, section 2.7, flowchart and paragraph proofs. Our objective for today, only one. I can write flowchart and paragraph proofs. So yesterday or last section we looked at two-column proofs. Today we're going to look at flowchart and paragraph proofs. Two different ways to write those proofs. So here we go. Vocab that we need to know, simple. Flowchart, paragraph proof, you'll learn exactly what those are. Okay, first we have to learn a couple theorems. First one, common segments theorem. Given four collinear points, A, B, C, D, arranged as shown, if we know that AB is congruent to CD, if we know that those two are congruent, then we can also say that AC and BD are congruent. Okay? The reason that we can say that is we're simply taking the segment BC here in the middle and we're adding that to both of those congruent parts. So if we add something to congruent parts, they're going to stay congruent. If I add a 5 to 3 and 3, I'm going to get 8. So the end result is also equal. Okay, so our second style of proof is the flowchart proof. Okay, this uses boxes and arrows to show the structure of the proof. So it kind of shows what depends on what and kind of the flow of where we get the information and where we go with the information to prove our proof. So here we're going to use a flowchart proof to write a two-column proof. So we're going to go back and forth today. We're going to switch between all the different types of proofs that we have. But they already gave us a flowchart proof. So we're going to take a look at this flowchart proof and see what it means. You see arrows on here. Those arrows represent what is needed to say the next step. So for example, to be able to say that the measure of angle 1 is equal to the measure of angle 3 right here, to be able to say that, I need to know that 1 is congruent to 3. Okay? How do I know 1 is congruent to 3? Well, it was given, right? Here's our given. So 1 is congruent to 3. So that's a given. And then because of that given, we can say the measure of angle 1 is equal to the measure of angle 3. Well, our other given is over here, right? Here's our given. And then because of that given, because they're complementary, we can use definition of complementary to say that they add up to 90. Well, and then to use this substitution step right here, okay, notice that we need both of these. So we have arrows coming from both of them into that one step. I can't go straight from definition of congruent angles, measure 1 is equal to measure 3, to being able to say this whole thing. That doesn't make sense. And same thing, I can't jump straight from here to here. I need both of them to come together to form that. Okay, so if we take a look at that again, now let's make the two-column proof. Well, I'm not going to rewrite everything. I'm going to put numbers next to our steps as we go. So we're going to start with our givens. Okay, we always start with our givens. And I'm actually going to put the givens in the same step. Okay, I put the givens in the same step. That's one step. Moving forward, I know if I'm going from here down to here, that's all I need. So this could be step 2 right there. But before, as we said, before I can go over to my substitution step, I need to know this one. So that's step 3. So this way I have 1 was my givens, 2 and 3 before I get to that substitution step, which is 4. I need the 2 and the 3 before I can get to 4. And then of course simply our last one is 5. So here's our two-column proof. You'll see exactly the order that we talked about, and the reasons why were because of that flowchart proof. Let's move on. Here's another one. Okay, try to think about which order you would put these in. Okay, think about what order these need to go in, and we'll take a look. So pause it, come on back. Okay, so let's take a look. We know that our given is always our first step. So if our given's our first step, that has to be 1. Well, the only place that we can go with that, we follow our arrow, is here, is 2. You might think that this is 3, but we can't use that one until we have this one. So that has to be 3. Now that I have 2 and 3, I can come down to 4, and then finally 5. Remember, if there are arrows leading to it, you have to do those arrows before you can come together to that one. Again, we look at our final two-column proof, and there you go. Moving on, we have to go backwards now. Now we're going to take that two-column proof and we're going to make a flowchart. Okay? It's the same idea. What depends on what? If it depends on it, if it needs it to exist, we need an arrow going from it. So for this, when we look at it, we've got B as the midpoint of AC. That's our given. So that's going to be by itself. So I'm going to put 1 by itself. Definition of midpoint. Well, that stems right from it because we're talking about midpoint there. So I'm going to draw an arrow and I'm going to put the second one. Definition of congruent segments. Well, again, I'm going straight from step 2 to step 3 here. because I went midpoint to definition of midpoint to definition of congruent. We said they were congruent, now definition of congruent. So now step 4, segment addition postulate, kind of comes out of nowhere. Okay, that doesn't have anything to do with the AB is equal to BC or any of the other ones. So really step 4 is on its own there. Now substitution, whenever we substitute, we're going to have more than one arrow. We need more than one step to be able to substitute. We need to know the fact that AB plus BC equals AC, which was step 4. So we need that. But we also need the fact that AB is equal to BC. So we need 3 and 4 to be able to say 5. And then from 5, we're just simplifying, so we go to 6. Okay, so that's a basic idea. Now, if we go here, this is basically what mine looked like. It's just written out completely, and this is what you should do in your work. Your statement goes in the circle, the reason goes underneath. But you'll look, it's the same exact kind of pattern that I had from before. So there's how to take a 2-column proof to a flowchart proof. Okay, I want you to try it out. This is a basic one. There's 4 steps. Okay, pause it, try it, see if you can get it. Okay, let's take a look at the answer. We're going to start with our given, and then our step 2 has nothing to do with our given. 2 congruent to 4 has nothing to do with 1 and 2 being supplementary, 3 and 4 being supplementary. Linear pair theorem is just something we know, so that's by itself again. Now we need to know 1 and 2 to be able to use congruent supplements theorem. So that's why you have arrows coming from 1 and 2 down to 3, and then simply an arrow going to 4. There we go. Moving on, a couple more theorems. Vertical angles theorem, this is something you've already known. Vertical angles are congruent. So if we're looking at vertical angles, if we have vertical angles here, we know that vertical angles are congruent. We could also say that these are congruent. So opposite angles and those lines crossing, vertical angles are congruent. Our next one that we have, 2 congruent angles are supplementary, then each angle is a right angle. So this is saying if I know that I have 2 angles that are supplementary, so they add up to 180 degrees, and they are congruent, the only way they can both be congruent is if they're both 90 degrees. So they're congruent and supplementary, they are right angle. And notice in parentheses, whenever you see this in parentheses, that's what we're going to have to write down for our proofs. So for our justification, later on when we use this theorem, we can use just what's in the parentheses. It kind of shortens it a little bit for us. Our last type of proof here is a paragraph proof. Okay, style proof, it's basically just in a paragraph form. Okay, so you're writing sentences. This is more of what researchers might do, and scientists. They are giving paragraph proofs. They're explaining step by step what they did, but they're not doing it in a 2-column proof format or a flowchart format. They are using paragraphs. They're using sentences. So really what we're doing is we're taking a 2-column proof and we're going to turn it into a paragraph proof. But first we're going to go the opposite way. We're going to take this paragraph proof, we're going to turn it into a 2-column proof. And what you're going to see here is that everything is spelled out in the paragraph proof. It says it is given that measure of angle 1 plus measure of angle 2 is measure of angle 4. That's step 1 right there. So that's 1. Okay? If we look again, if we look at the next one here, 3 and 4 are supplementary by the linear pair theorem. That's a different step. Okay, so there's step 2. The next step says, so 3 plus 4 is 180 by definition. Okay, so that's step 3. And then finally, by substitution, that is true. So if we look, we've got 4 steps there. 1, 2, 3, 4. We just have to be able to put them in a 2-column proof with a statement and a justification. So for step 1, our statement is measure of angle 1 plus 2 is equal to measure of angle 4. Our reason, it's given. There you go. Then step 2, 3 and 4 are supplementary, so there's our step, and then our justification, our reason is linear pair theorem. Our step 3 is 3 plus 4 is 180, and it says by definition. So we need to know that is the definition of what we talked about previously. So that is the definition of supplementary. That would be step 3. And then finally, our substitution, that's our justification or our reason there. So here's our 2-column proof that we just talked about. Hopefully that makes sense if you look back at it. We're going the other way. We're taking a 2-column proof, we're writing it in a paragraph proof. Well, all we have to do here is take each sentence, or sorry, each statement and reason and create a sentence out of it. So we're going to create a sentence out of each of these statements. So the first one might say, it is given that 1 and 2 are complementary. Then we could say, by the definition of complementary angles, measure of 1 plus measure of 2 equals 90. Okay. We could then say, By the vertical angles theorem, 1 is congruent to 3, 2 is congruent to 4. By the definition of congruent angles, that means, okay, you get the point. We're making it flow a little bit. We're putting transition words in there. If you take a look at their paragraph proof, it's very similar to what I was saying. You can look out and you can point to each sentence here, and each sentence really is a new step that we saw in that 2-column proof. Okay, you can try it out if you want. Otherwise, just take a look at this. It's given vertical angles, transitive property. Let's take a look at the end result here. It is given that 1 is 4. By vertical angles theorem, that's step 2. By the transitive property of congruence, there's step 3. Also by the transitive property of congruence, there's step 4. So you can see 4 specific sentences, 4 specific steps. That's all a paragraph proof is. Here's our quiz. You're going to take this 2-column proof and turn it into a flowchart and a paragraph. Pause it, come on back. Okay, so let's take a look. Here's our flowchart proof. You'll notice that we need that vertical angles theorem. We need that vertical angles theorem to say the transitive property. We also need it to say this one. This is kind of tricky because you got that whole triangle thing in the middle here. That you need this, this, and this. Okay. Next one, paragraph proof. If we take a look at that, simply one sentence at a time. So that's it for flowchart and paragraph proof. Hopefully you understand a little bit more about the different types of proofs in section 2.7.